All right, this is the last lesson of this unit. We're going to kind of switch gears and we're going to be talking about recursive rules with sequences and functions. So what you are probably wondering is like, what's recursive? So what we've been doing is called explicit. And that kind of means that it's determined by the position of the number n. So determined by position of n. Whereas recursive uses the previous term. And I'll show you what I mean. It gives the beginning term or terms of a sequence and then a recursive equation that tells how, so basically it tells us what the new number is based off of the last term or the preceding term. So determined by previous term. So if we took, for example, let's say we took the equation a sub 0 equals 1, and then our equation is n minus 1 plus 4. So this is kind of what you'll see a lot. It's either going to be n minus 1 or n plus 1, and that's again signifying the previous term. So to find a sub 1, I would say, all right, I'm going to take a sub 0 and add 4. To find a sub 2, I would take a sub 0. To find a sub 2, I would take a sub 1 and add 4. To find a to the third, I would take a to the second term and add 4. So what it's going to end up being, in this case, a sub 0 is 1. 1 plus 4 is 5. A sub 1 was 5, so this is going to be 5 plus 4, which is 9. And then this is 9 plus 4, which is 13. And again, it goes on and on and on and on. So what we are looking at is we're using the previous terms to describe the sequence and series. So another example, let's say, all right, our first term is 1, and then our recursive equation is basically multiplying the previous term by 3. So a sub 2 is going to be 3 times a1. A sub 3 is going to be 3 times a2. A sub 4 is going to be 3 times a to the third. So again, this is 3 times 1, which is 3. 3 times 3, which is 9. 3 times 9, which is 27, and you could go on and on and on and on. So the rules kind of, again, just super, make sure you have these rules written down. Get them pulled up here. So the arithmetic sequence you can see on the top, and then a geometric sequence was like our second example where we are multiplying. So we did 2 examples of each. The next step is going to be, again, how do you write recursive rules? So let's say that we have 3, 13, 23, 33, 43, going on forever. So one of the first steps is to identify like a first term. So what is my first term going to be? And then after that, I got to figure out kind of like what's happening or what's my common difference. So I can tell that my first term is 3. So I'm going to plug that in here. And then my common difference, if we look up here, we've got, see here, plus 10, plus 10, plus 10, plus 10. So it looks like it's going to be adding 10. So whatever term I'm looking for, whatever number I want, I need to take the previous term, so n minus 1, take the previous term and add 10 to it. Now you always have to state what the first term is. Recursive doesn't work unless you have a starting point. So you always have to say either what a sub 1 is or a sub 0. You have to state that, or else your answer is not correct. All right, one other example like that. 16, 40, 100, 250. So this is most likely going to be geometric. Again, my first term is 16. My common ratio is, well, let's figure that out. How do we get from 16 to 40, 40 to 100, 100 to 250? That one's kind of nice. That's multiplied by 2.5. And I bet if I multiply 40 times 2.5, I get 100. 16 times 2.5, I get 40. So my common difference is 2.5. So again, just going off of my kind of template here, a sub n, again, you could call it k, you can call it whatever you want. A sub k equals 2.5, and then that's going to be multiplied by the previous term. Again, I have to include my starting point, which is 16. So whatever my previous term is, which I showed right here. Oh, I used k's and n's. That's not correct. You gotta stay consistent. All right. So that worked out good there. Let's do 2 more examples. Write a recursive rules for a special sequence. So let's look at 1, 1, 2, 3, 5. This is a special one because what we are doing is we are beginning with the third term in this sequence. Each term is the sum of the 2 previous terms. So sum of 2 previous terms. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. So a sub 1 is 1, a sub 2 is 1, and then this time we need to take the second term, so 2 terms ago, and then add it to the most recent term. So again, this is kind of a special one, a common one where, hey, I got to go 2 terms back. If I'm looking right here, I got to take 1, 2, I got to take this one, and I got to take this one to equal my third one. Again, if I was looking for 4, 4 minus 2 is 2, 4 minus 1 is 3. I would be using the fourth and the third and the second term to find the fourth one. Oh, and again, make sure that you include this in your answer as well. In this case, I need 2 terms. So I can start at a sub 3. Last kind of funky example, 1, 1, 2, 6, 24. So this time I'm going to say that a sub 0 equals 1, and then a sub 1 equals 1 multiplied by a sub 0. A sub 2 would be 2 multiplied by a sub 1. So again, what am I kind of doing? I'm going to be I'm increasing what number I am multiplying it by. So if we take this, again, what is happening? This number is increasing by 1, and this number is increasing by 1 as well. That's my previous term. So again, 2 times 3 is 6. 6 times 4 is 24. 24 times 5 would be our next answer. So the recursive rule for this is, again, we take our a sub 0, our starting point, and then to find the next term, we need to take whatever n is and multiply it by the previous term. So that's where, again, if we looked right here, a sub 1 used 1, a sub 2 used 2, a sub 3 used 3. So our answer is going to be whatever term you're looking for it, multiply it by the previous term. So if I was looking for the 100th term, I would say 100 times whatever that 99th term was. The last part of this lesson is iterating a fraction. So iteration involves the repeated composition of a function f within itself. The result of one iteration is f of x. The result of two iterations is f of, so it can be a lot of parentheses, f of x. The results of three iterations, I think you probably get the idea. Okay, it's going to keep compounding like that on and on and on. So you can use iteration to generate a sequence recursively. Begin with an initial value of x sub 0, and then let x sub 1 equal f of x sub 0, x sub 2 equal x sub 1, and so on and so forth. So x sub 1 equals f of x 0. X sub 2 equals f of x sub 1. X sub 3 equals f of x sub 2. And again, you can go on and on and on and on. So let's go ahead and do this last example here of find the first three iterates. So x1, x2, and x3 of the function f of x equals negative 3x plus 1 for an initial value of x sub 0 equals 2. So for the first one, again, the function, to find the first term, I'm going to use x sub 0 inside of my function. So this is like f of x sub 0, which again, that means we plug in every time I see my function of x, I'm going to plug in a 2. So I'm going to write negative 3 times 2 plus 1. So this is going to equal negative 6 plus 1 is negative 5. Now, all I have to do is say, all right, I want to find my second iteration now. Well, I'm going to use the first number. So now I'm going to use negative 5. So every time I see this equation, I'm going to plug in a negative 5. 15 plus 1 is 16. So one more time, because it said to find the first three iterates, I'm going to take it from the second one, which is right here. So negative 3 times 16 plus 1. 3 times 16, that's going to give me negative 48 plus 1, which is negative 47. So my first three terms are negative 5, 16, and negative 47.